Hello everyone, I hope people having a very good time. So this are another question related machine learning, that is plot hyperplan for the following points. Now we have to find the hyperplan and maximum margin. So we have some data point and we have the Cornell function. So now we can tell me that we can easily use this point and we can find the hyperplan, but it's not possible. Let me show you why it's not possible. Because if we draw a graph using this point, then let me draw it. 2 1 and 2. So at first point is 2 and 2, 1 2 and 2 is 2 and 2 is there, 2 and minus 2 will be 2 and minus 2 will be there, and minus 2 and 2 will be there, and it was there. So for this negative data point it will be there. So here this point to this point we can find a hyperplan. From this point to this point you can find a hyperplan. From this point you can find a hyperplan. From this point to this point you can find another hyperplan. So there is too many support vector are there, 1 2, so it is difficult to us to get which support vector we have to use. So that's why we have to convert this point to higher dimension. Okay, so after converting this higher dimension we can easily find the hyperplan. How we will go the higher dimension? So using this Cornell function, at first we have find the new point for each of every point using this function and this condition. So let's check for 2 and 2, this point. For this point here, suppose x1 is 2 and x2 is this 2. Okay, and we have to find the condition. If this condition is satisfied, then we will find the value for this and this equation. So let's check this condition is satisfied or not. So it will be 2 square plus 2 square root 8. Okay, this condition is satisfied. So now we have to use this function for the first equation, that is 4 minus x2 plus x1 minus x2. 4 is 4, we know the value of x2 is 2, so minus 2, and plus we know value for x1 is 2 minus 2. For this equation 4 minus x1 plus x1 minus x2, 4 minus 2 plus 2 minus 2, 2 to minus, so we get only 2 here and 2 here. So one new data point will be 2 and 2. Okay, now we have to find for next data point, that is 2. For 2 and minus 2, here x1 value is 2 and x2 value is minus 2. Let's check this condition, is it satisfied or not. So it is root over x1 square plus x2 square greater than equal to 2. So you know this value will be root over 8. This condition is satisfied. So now we have to calculate this equation value. We know the equation is 4 minus x2 plus x1 minus x2. This equation is 4 minus x1 plus x1 minus x2. So for this data point here, 4 is 4 and x2 value, you know x2 value is minus 2, minus plus 2, and x1 is 2 and x2 is minus 2, then plus 2. Again 4 minus 2 plus x1 also 2, and this one is plus 2. So we get here 10 and here is 6. So new point will be 10 and 6. So we already find for this data point. Now we have to find for this point. Okay, so for -2 and 2, so here x1 will be -2 and x2 will be 2. Let's check this condition, is it satisfied or not. So it is root over x1 square plus x2 square greater than or equal to 2. So root over, it is 2 square plus 2 square, so it is root 8 greater than 2. So this condition is satisfied. Now we have to find the value for this function and this equation. Okay, so 4 minus x2 plus x1 minus x2, and another function is 4 minus x1 plus x1 minus x2. We know the value for x2 is 2 minus 2 plus x1 is minus 2 and x2 is minus 2. So x2 is 2, so it is minus 2. 4 minus x1 is minus 2, so it will be plus 2 plus x1 will be minus 2 minus 2. So here the value will be 6. Here the value will be 10. So we got our new point. Will be 6, 10. Minus 2 and minus 2. Here x1 will be minus 2 and x2 will be minus 2. Let's check this condition, is it satisfied or not. So we know the value will be root over 8 greater than 2, so it is satisfied. So let's find out this value. 4 minus x2 plus x1 minus x2, 4 minus x1 plus x1 minus x2. So here the value will be 4 and minus plus 2 plus minus 2, it will be plus 2, and this one will be 4 minus minus 2, so it will be plus 2 minus 2 plus 2. Okay. So the value will be 6 and here will be 6. So the new point will be 6 and 6. Now we have only this negative data point, but in case of negative data point, no point will be satisfied for this condition. Okay, let me show you. That is for 1 and 1. Here x1 will be 1 and x2 will be 1. Let's check this condition is satisfied or not. Root over 1 square plus 1 square is greater than 2, so it is the root 2 and 2, so its condition is not satisfied. So all of this value will be same. So we got the final output, that is for positive it is 2 and 2, then 2 and 2, then 10 and 6, then 10 and 6, then 6 and 10, and then 6 and 6. And negative will be same because its condition is not satisfied. So negative data point is 1 1 and 1 minus 1 minus 1 1 minus 1 minus 1. So we already get our new data point, so we can draw the hyperplane right now. So for negative data point, we know the value is 1 1 is there, 1 minus 1 is there, minus 1 minus 1 is there, and minus 1 1 is there. Okay, and for this value 2 and 2, 1 2 and 1 2, 1 is there, 10 and 6, 1 2 3 4 5 6, 10 and 6, 1 2 3 4 5 6. So this mass will be there. And then 6 and 10, 6 1 2 3 4, and 10 is will be there, and 6 and 6 will be there. Okay, so look, now we can easily draw the hyperplan. Look, there is only two support vector, so we don't, without any confusion, we can draw the hyperplan. So in hyperplan we got two support vector, one is this one is this one. So there the point is, we know this point is 1 and 1, this point is 2 and 2. So this is support vector 2, suppose this is 2 and 2, and this is S1, this is S1, this is 1 and 1. Okay, and another thing is we already got the support hyperplan. Now we have only find the maximum margin. Maximum margin means this distance. Okay, maximum margin. So for finding the maximum margin, we have to find out the value for alpha 1 and alpha 2, because we have two support vector S1 and S2. And if the question is only like plot the hyperplan for the following points, then this mass is answer. Okay, and if there is another things like maximum margin, so that time you have to continue. Okay, let's find out maximum margin. For this we have to find the alpha 1 value for alpha 1 and alpha 2. How you can find the value for alpha 1 and alpha 2? So from here we got get two support vector. One is S1, value is 1 1, and S2 value is 2 and 2. Okay, so we have to add the BIOS with these values. So suppose S1, we got know the value is S1 is 1 1 1 1, and S2 is 2 and 2. We have to add BIOS, so we add 1 as a BIOS. Okay, so here now we have to remember one formula, that is easy one. The formula is alpha 1 S1 to finding alpha. Okay, alpha no, okay, you can memorize this formula, but I have better option for you. Like this way you can easily understand this and easily get these things. At first just write alpha 1 and S1, then take some space, then plus, then alpha 2 S2. Okay, then equal to again alpha 1 S1 plus alpha 2 S2, then equal to. Okay, so in the case of for finding S1 value, you have to put S1 both sides, S1 S1, and look, S1, this is 0.11. we know that 11 it belongs on negative side, 11. Okay, negative side, so you have to put here -1, and 2 is from S2 is positive. Okay, so this is value for S2, just put here S2 this is positive. So we got two equation number 1, equation 2. You can memorize this equation or you can follow my step. Okay, so now So let's put the value there. Equation 1. For equation 1, alpha 1 s1 s1 alpha 2 s2 s1 equal to 1. So here alpha 1 value alpha 1 is 1 1 1, sorry, s1 is, and again s1 is 1 1 1 plus alpha 2 s2 is 2 2 1, and s1 is 1 1 1 1 1 1 equal to 1. Now alpha 1 1 into 1 1 1 into 1 plus 1 1 into 1 plus 1 plus alpha 2 2 into 2 2 into 1 2 plus 2 into 1 2 plus 1 into 1 1 equal to 1. So we got alpha 1 2 3 alpha 1, we got 3 alpha 1 plus 5 alpha 2 equal to 1. Now on mistake, that is it will be minus 1, okay, because this is for s1, this minus 1, minus 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 1, okay. Now we have to again find out for equation number 2. Let's put this is equation number 3, okay, and for equation number 2, that is alpha 1, we just directly put the value, okay. For equation number 2, alpha 1, no, s1 is 1 1 1, s2 is 2 2 1, alpha 2 s2 2 2 1, again s2 2 2 1. Now the output value is plus 1. So alpha 1 2 into 1 2 into 1 2 2 into 1 2 plus 1, okay, plus alpha 2 2 into 2 4 plus again 4 1, only 1. So the value will be, it is 5 alpha 1 5 alpha 1 plus 4 4 8 1 9 9 alpha 2 equal to 1. This is equation number 4. Like from 3 and 4 we can easily get the value for alpha 1 and alpha 2. So in equation number 3, that is 3 alpha 1 and 5 alpha 2, that is 5 alpha 1. So if we multiply this 3 alpha 1 with 5 and this one is 3, then we can easily find the value for alpha 2, okay. Let's find out. So what we'll do now, like equation number 3 into 5, because that alpha value is 5, okay, and then we subtract from equation number 4 into 3 1, then plus 5 into 5 25 alpha 2 equal to 5 into 1 minus 1, that is minus 5, okay, and and equation number 4 we have to multiply with 3, okay, that is 15 alpha 1 plus 9 into 3 27 alpha 2, okay, and we have to again multiply with 3, that is 3. Then we have to subtract this minus minus minus. So here we have only minus 2 alpha 2 equal to minus 8. So alpha 2 value equal to 4. So we already get a value alpha 2. So if we put this value in equation number 4, then we can easily get the value for alpha 1. So let's do here. Put alpha 2 equal to 4 in equation number 4, that is 5 alpha 1 plus 9 alpha 2 equal to 1. So 5 alpha 1 plus 9 into equation number here we get alpha 2 equal to 4 equal to 1. So 5 alpha 1 equal to minus 9 into 4. Alpha 1 equal to minus 9 into 4 by 5. It could be minus 7.2 something. So we ignore the float value. We just write here minus 7. Okay, almost. That is alpha 1. Now we have to find out the weight vector. Formula is I1 and N. Okay, so it will be Si and Xi. So here we have a S1 into alpha 1 plus S2 into alpha 2. So we know the value for alpha S1 is 1 1 and 1 into alpha 1. Alpha 1 means minus 7 S2. Now value for S2 is 2 2 1 and alpha 2 is 4 into 4. So we got here minus 7 and plus we got here value 8 8 and 4. So we got the final value is 1 1 and minus 3. Here in this point, here first 2, remember first 2 was our weight and list of the we take 1 that time in BIOS. So in this case first 2 is weight, 1 is weight and BIOS is minus 3. So this 2 will be 1 will be weight, it will be 1 and by minus 3. So we have to find the maximum margin, that will be 1 2 3 4. No, our hyperplan was this 2. So now we got BIOS 3, so our BIOS will be there. So we got our final maximum margin. I already provided this PDF in video description box. Please check.